All right, let's see. I should be able to hear me. Let's see. Sorry, software I was using to display the chat on the teleprompter the free trial period has expired, so I'm having to toggle back and forth. But you should be able to hear me. So let's go ahead and see who's here. Go ahead and say here if you're in chat. Come on, one more. There we go. All right. So, up here is on the screen the code that we had from last class. And I wanted to go ahead and clarify the approach. I was thinking about it after class, and I think the better approach would be to walk you through how I would figure this out using the book and its definitions rather than just trying things with code. Because I was trying things to see where, like, the edge cases where things would break, and I don't necessarily think that's the best approach when you're first learning the concept. So let's go ahead and finish up the code that we were looking at previously. I've gone ahead and deleted all the code that was in here that was commented out, and I've just left, and I'll go ahead and delete this too. We're not using any of that anymore. So 1, 2, 3. And I execute it, and it doesn't work. Now, the reason why it doesn't work is third here is ambiguous. And the reason why is because logic implements test interface and test interface 2, and they both have a third variable. That third variable is false in both cases, but it doesn't matter because it doesn't know which one to use. So, does anybody know offhand how you would distinguish between two different interface variables like this, or default methods? Curious if anybody happened to look it up themselves. Did anybody think about it? Anybody have any ideas? How would you distinguish between this interface and this interface? The answer is kind of painfully obvious, and you'll see here in a second. No suggestions? Okay, so you just put in which interface it comes from. So, kind of painfully obvious, actually. So, let's say you didn't want to have any logic here. You don't want this method at all in this class. Well, unfortunately, you can't do that. Let's try that. Because are both true has defaults in both interfaces. So and I wanted to bring this up. I just Googled it, and I think this is a nice explanation. Classes take higher precedence than interfaces. So if a class D has the method, it'll take precedence over the interfaces. Derived interfaces or sub-interfaces take higher precedence than interfaces higher up in the hierarchy. So what that means is if you have a default here and a default here, they override each other, and then you have a class C, and it extends B, which B extends A, then it'll use B's. But here's the case that we're in. In case 1 and 2, or Rule 1 and Rule 2 are not able to resolve conflict, let's make sure you can see that on the screen. I will bump up the size a little. Yeah, there. That should make it easier to read. They're not able to resolve the conflict, then the implementing class has to specifically override and provide a method with the same method definition. So this doesn't work because we have to provide a method with this definition. We provide it, and it works fine. But what do we do here inside? Let's say we actually just want to call are both true from test interface 2. Does anybody have a suggestion on how that will work? It's not a trick question. You can just make a guess. We'll sit here until one of you guesses. No. That would be kind of amusing, but a waste of time. Well, I won't do that to you. Here's what you do. Execute, and it works. So true, 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 true. Test interface 1 calls this method. They're true. Now, let's do this. They're all false because it's using third. And here's where we got into conundrum, is adding static. So are both true and third, or third now is static and is able to be used by are both true as a default implementation. So people asked, or yeah, at least a couple people said they were having confusion on static. Did anybody look it up? Is anybody still confused on how static works? So everybody understands static? That's what you're telling me? I don't need to go over it and explain it to you? Because that's what silence means. There we go. Some life. Okay. So here's my best recommendation when you don't know how something works, and in particular when you have a textbook. Generally, first answer would be Google it. But unfortunately, when it comes to some complex topics, you're going to find there's two scenarios. One, let me rephrase that. Three scenarios. One, the documentation exists, but it's not clear. Two, the documentation just doesn't even exist. And unfortunately, that does actually happen for professional tools, like Ethereum in particular. I've ranted about Ethereum's documentation being horrible and just not being documented in certain places. And like when I say ranted, I mean I've written chapters and peer-reviewed articles about it. So, and third cases, or fourth cases, and the third and fourth cases are you find other people explaining it, generally, unfortunately, almost always incorrectly. Occasionally, you'll find somebody explaining it correctly. So it's sort of this where the phrase "Google foo," like how well are you at searching the topic, matters more than anything else, because you need to wade through all the wrong answers. And so that's in particular why I spent a long time finding this book, and I really think this is a very good book for explaining the concepts. So my recommendation is to look at the index. And the index on page 1053, it's a thick book, has static in it, and it has a couple bold lines and a couple unbold. So my recommendation is to first look for the first page number. So 44, that's the first page static is mentioned. Let's go turn to that and find where, sorry, Mike is in the way. So it says, let's see here. Line 6 through 25 of figure 3.2 declare method main. A key part of enabling the JVM, the Java Virtual Machine, to locate and call method main to begin the app's execution is the static keyword, line 6, which indicates that main is a static method. A static method is special because you can call it without first creating an object of that class in which the method is declared. In this case, class account test, which is the figure that they're showing, and then it says, we, the book, discuss static methods in detail in Chapter 6. Okay, so what it means is, so far, static method, excuse me, static methods excuse me. Sorry about that. So we know that there are things called static methods, and they can be called without first instantiating the class. So let's come up here. We see the word static main. Okay. Well, let's do it this way. Public test or void test. system.out. Test on static test2. Comment these out for right now. And run this. Test static method. It worked, it compiled, it ran. Notice we called my class, which is the class that we're in, and we called the method, but we didn't create an instance of my class. We're calling this method directly on my class itself. Now, notice the difference here. Hopefully I typed that right. I did. So first we call the static method implementation, and then we call the non-static method implementation. Notice the non-static method implementation requires you to create an instance of the class myStatic. In the book, I'll skip ahead. I think it's let's look back at the index. I lost the page, so let's refind it. Okay. 111, I believe, is the page it explains, or it talks about math.pal. Yes, it is. The math variables, or the math methods. So math.pal, math.square-root, math. There's a full list of them. Max, floor, log, min, sine, square root, tangent, etc. You would call math.square root or math.abs for absolute value. And you don't have to call math, my math equals new my math.pal. And there's some benefits to that. For now, I think it's worth just knowing that the static methods are associated with the class, not instances of the class. And the same thing is true for I think that's right offhand. It is. So here it is. So this is, ignore this for a second, I'll explain it. But back here, public. So is it public or private or package or etc. Static, string named tag. So we know what this means is this is a string named tag that's associated with the class itself. And then we're setting it, and this is a nice way of making it so if you rename your class through, and if you're using an advanced IDE like Android Studio or Intellij or Eclipse, etc., you can rename all my class. You could be like my super class, and that's bad formatting. We'll talk about that here in a second. And it would automatically add the super in everywhere. And so therefore, the default behavior would be something like this. And I just find this is cleaner. So what you're doing is you're getting the class name, you're getting the class of the class name, which is technically a type of object, which is, this is just magic hand waving for a little bit for right now, so just accept it. And then you get the simple class name, and you get my class. I think it's get name. Oh, it won't show you here because I'm not using packages. But get name will produce a much longer string, where get simple name will just use the name of the class that's visible right here. So it's just something to know. Basically just copy and paste this and then change this to whatever your class name is. And then you can have logging tags for what class the call came from, basically. Here's how it works in Android Studio and a lot of other logging systems. You would go log.d tag string here. And this would work in Android. The D is the type of level logging. I'll explain that at some point later. But it's D for debug. You would log to the log cat, which is its log system, with the unique name tag, which is my class, and this a separate string here. So basically it makes essentially a comma separated value string with a bunch of values, and you can easily filter them. Makes it nice and clean. So does that make sense on the logging concepts of how you would have a string associated with the class itself and a method, or here we are, test2, that's associated with the class itself, versus just normal classes or normal methods that are associated with instances of the classes? Does that make sense to everybody? And to be honest, static is something you should try to avoid for right now until you know specifically why you're using it. In this case with the logging, you want it because the tagging you're using to debug which text file of source code are the logging statements coming from. And that would be useful. So where was I? Tag here. Delete this. Yeah, I hate auto-completion where it, like, look at this. You type double quote, and it creates two of them. I don't need a second one because I'm typing over the second double quote. So you have my class test. So, does that make sense? Okay. So let's see. Does anybody have any questions? Static is really, really powerful and really dangerous to use in certain ways. It can cause memory leaks if you're not careful with it. You can have unexpected behavior. It all depends. At the end of the class, at the end of the semester, I'll start talking about it more. Yeah, with great power comes great responsibility and being sued by Marvel. Or, soon, the Stan Lee estate. If you're not familiar, the news is that Marvel might lose the majority of its tentpole characters in 2023 or so. Personally, I think that would be great for copyright, but that's just me. Okay, so that's an aside. Anyways, but yes, static is very powerful. At this point, I would only recommend using it in two cases, where you're using something like this for logging, or making a tag for logging. There's nothing special here. It's just a string. But convention is that you use the name tag. That's just the convention. And then using it on main methods like this. Try to avoid, for now, static methods. I did want to, also generally try to avoid using default methods for now. I just wanted to show you them so that you were aware that they did exist now in Java, so that if you run into them, you know what they are. Because if you notice, we're inheriting are both true from multiple sources, which breaks the concept of Java not being a multiple inheritance language. That's a key concept to understand. Technically, it still is only... It's not technically breaking it, because logic still only extends object. Remember, any class that doesn't say extends object does it behind the scenes anyways. That's important to remember. So, let's go ahead and uncomment these. Arraylist, a list equals new arraylist for... Oh, you know what? This is interesting. I don't know if I've talked about generics yet, but so Arraylist won't work like this, and let me show you why. Let me show you what happens. It doesn't know what type of Arraylist it is, and what does it mean by that? It means this. It wants to know what type of Arraylist is it. What's it going to store? And in this case, instances of logic. Oh. I also got to import it. My bad. Import. List. Honestly, I never import it manually. Java Arraylist import. And now I've lost my cursor. Oh, apparently they now have Java on W3 schools. Java Util Arraylist. So that might be a really good resource, actually. There we go. What an array list is, basically a container that does the nice, you're familiar with creating arrays like this. We call them C-style arrays, because they're popularized or maybe first implemented this way. I think the correct syntax, yes. Now, you see this code versus this code. And what's the one big thing that jumps out to you? What is unique? What is completely something that one of them has that another doesn't? Yes, that is correct. The C style has a defined size right here. Now, technically, so does the array list. You put a number in there, and it will create also. But this isn't a static array list or a static size. I can go 10 and then it works. And we'll notice, obviously, this is more than 10. 47 to 22, so 25 lines? Maybe 26. Yeah. Way more than 10 lines of logics being added to a list. So all this number was a hint to array list on the original size. Now, this flexibility comes at a performance cost. When this array list, A list, hits the 11th object that it wants to store, it has to make a new internal C-style array list, copy over all the data, store the value from the first internal C-style array list to the second one, then start adding new values. And it has really nice, like, basically proven efficient strategies for how much data to pre-allocate for space storage and things like that. And it does it very nicely. But it's important to know, under the hood, there's a lot of magic hand waving going on that includes potentially a bunch of these to make this work, so that when you, as the programmer, zero. This gets the zero index a list dot remove. This removes the first index. I think all that syntax is right. Yeah. As this is happening, underneath the hood, there's still actual memory being involved, but I don't have to manually keep track of it. So, okay. So that was pretty much that I wanted to cover from this stuff that we were talking about. And honestly, we've covered a lot of material so far. So what I planned on doing was going through and more talking about software engineering principles versus software development specifics for Java. And what do I mean by that? So software development is what we're doing right now. We're just writing code to complete, like, requirements. So programming assignments, programming competition problems, things like that. That's software development. And this is sort of my own definition, more than necessarily a textbook definition. Whereas I consider software engineering is more of a understanding of how you're going to design an entire system to solve multiple problems, or solve a complex problem. So if I need to write some code that takes two numbers and adds them together, or adds their absolute values together, so -5 and 5, you add their absolute values together, you get 10. Okay. There's literally only going to be like maybe 2 or 3 ways you could write that possible. And most likely, if people are trying to be efficient, they're going to come with a symbol or a simple public int add int R1, R2, math, turn R2. Print line, new one, class -5, 5. Execute. I'm amazed at myself. It worked. But my point is, if you have a developer who knows what they're doing, they're basically just going to write this method. There's no simpler way, and there's realistically no good, more complex way. Unless perhaps the math library happens to have this built into it, but that seems silly. So that's software development. Software engineering is designing a more complex system. So if I wanted to write a math library, like the math here, that's a much more involved, complex system that you're having to design. Well, what methods are we going to include? You're deciding what are you going to support and what aren't you going to support. How are you going to design the system? How are you going to name things? How are you going to, like I called them arg1 here and arg2. You could make a convention for your entire library that you have arg1, arg2, arg3, or you could make up other names, param1, param2, etc. And does that make sense where I'm going with this so far? This is pretty much all we're going to talk about the rest of the day. And then, not tomorrow, but the next class, what I'm going to do is I'm going to run you through installing. I believe I might actually, I know I've said Android Studio a lot, but I might actually have you install the Ide, which is technically the Android Studio. It just doesn't come with Android. So it might be better for our use case. So, but I'll walk you through that, and if you have any questions, there will be a video reference, and I might even actually, what I'm going to do is, once we walk through it, I'll go ahead and, I don't know how long it'll take me to do it, but I'll edit it and clip it out into a separate video. So, does that make sense? Any questions? Because I was going through Android Studio and looking to set up simple assignments for you. And honestly, I think it's overly convoluted right now for beginning developers. I don't like I don't think Kotlin and the default libraries that it recommends and uses are actually beneficial to novice developers. I'll put it that way. But I am more of a configuration over convention person, which is wrong by a lot of people's standards. And this is one of the things I'm going to talk about here in a few minutes. So, so let's see, chat. Sorry, I'm not looking at the teleprompter today. Like I said, I don't know how much that software is. I'm going to have to look into it and see how much it is. Unfortunately, Windows will let you rotate the screen in 90-degree increments, but it won't let you rotate this way or this way, which is absurd to me, but yay, Microsoft. Okay, we have somebody typing. We'll give them a minute. Yeah, you can use Intellij Ide. I think that's what I said. Did I not say that? If I didn't say that, I misspoke. That's what I meant. I might have called it the IDEA IDE. Yeah, no, it's the Intellij IDE. Intellij IDE is actually what powers Android Studio, but for some absurd reason to me, they don't make it nice and easy to just make Java programs in it. It has the capability, but you literally have to make an Android project and then like throw away all the Android configuration. And that's not user-friendly to me at all. So I'm not going to make you do that because, in my opinion, and that's why we've started using this website, JDoodle, I prefer for you guys, you all, to be able to try things out and experiment and see, basically throw spaghetti at the wall code-wise, try it out, and incrementally make improvements to your code. I think programming is a lot like math, where you need to learn addition and then subtraction, then multiplication, then division, and then you can start learning more complex things like geometry, algebra, etc. And so as you build up your skill set, you add more tools to your tool belt to mix the metaphor. So, all right. Okay. So, I will just open a new one of these and we'll go to the advanced. There we go. No. Oh, yes, actually. New folder. UI. New folder. New folder. Okay. Whoop. Delete. I created a file. New folder. Okay. So, how to describe this? One of the most important and difficult things to do as a software developer is knowing how to divide your code. Because let's come back over here and let's look at all this code. And you'll see here's an interface. Where's another one? Oh, here's another interface. Oh, down here's a class. And these don't need to be and shouldn't be in a single class like we have them here. So one of the simplest ways to get started is to start making what are called packages. And here's a simple example. Network, repositories, UI, logic. And if you start subdividing your program into logical, I want to be careful, I don't want to say modules because that has a specific meaning, but sub and component also has another meaning. But let's just say logical subsections. if you start putting all of your UI code in one folder and all of your repositories, which a repository or repo, are you guys familiar with that term in broader sense, not just in programming? I found it oddly a term not everybody's familiar with. I literally own a company that has repository in the name of it, as a side note, which is why I bring that up. I thought it was interesting. Well, it's a startup. It's not actually running yet. Anyways, all right. So repositories are central locations where you access and keep information. So I always think of them as the Library of Alexandria, where everything is stored and it's accessible. Yeah, it's just storage. You're right. And then other things like network. Well, the repository, the repo, like Git repos are the same concept. They're storages of information. The repositories can have local information, networked information. They can grab information from a lot of places. Well, we don't know how to do that yet, but it's worthwhile just to know that these things exist. Networking calls, we don't know how to do yet, but we do know they exist. I mean, we're using internet right now. UI, we don't know how to make UI, but we do know it exists. And logic, which is what we've been focusing on. So you can subdivide UI into different subsections. Let's say Windows, and let's say widgets. And in widgets, you will have, I don't know, button.java. And, whoop, no, button.java. Delete this, or rename, that's fine. Login.java. Okay, so here's enough to where you can I don't even think it has a main. Let's delete this. Okay. Yeah, it just didn't know what to do with that completely empty file. So right now, we've actually I've shown you a lot of different things that might not be apparent. So package, how you declare a package, UI.widgets, button. So this class is UI.widgets.button. So public static final. I haven't talked about final before, but let's go ahead and use it. Come up here. Widgets.button.tag. Now, remember I talked about UI.widgets.button was what was going to be called the name, and then simple name is just going to be button. Here's where I demonstrate that's the case. So, simple name is just this. The full name is the path plus the name. So, that makes sense? This is an important concept to understand, where the class exists and how you can name it uniquely and different things like that. So, example, generally, you don't actually name it this broadly. What you do is, edu. Let's pretend I was writing this program for YSU. I would go edu.ysu.csis.CSIS3701.example Java 005. Okay, and what this would mean is here's your global domain, here's subdomain, here's the project you're working on, and here's the team, I guess you could consider it, and then the projects. And then you would have .ui.widgets. Long, convoluted, but this provides a unique string, a unique identifier for so if I write that code and I have access to this, I write this code anywhere in any of my Java, it will know exactly what code I actually want to instantiate. That makes sense? It's basically just an idea of how to uniquely identify classes. Because button, what type of button? Am I a tailor and I'm talking about buttons that I sell? Oh, you mean a button I can click. Well, there's just two different types of buttons. So if you just use your name, otherwise you have to go edu, YSU, CSIS, CSIS 3701. It gets really, it's very inconvenient, basically. So in here, you could go button B equals new button. I mean, obviously, you would need to use this inside code, but, and up here in my class, you could do it like this, or like this. Did that not? Wait. Oh, I messed up. I left all that in there. There we go. So you can import, in your class say, here's my button, and here's the type of button I'm using. So it makes it really nice and clean, actual code. You're in here, if it's a UI class and you have a bunch of different widgets that you're working on, you can have button, text, line, circle, and then you don't have to know, am I talking about my widgets or am I talking about some other UI library circle? You can come up here and just check with the imports, or specifically define which ones you want to import. You can do this with the star, but that's really bad for efficiency. But because what happens if in this widgets package, and when I call it package, all it means it's a folder. You all know how Here, actually, really quick question. Everybody knows what a folder structure is, right? Does anybody not understand what a folder structure is? Like a hierarchy of folders? It's not a problem if you don't. We'll explain it. Because this is super... Let's make sure everybody who does know, please say you do know. Okay, the reason I ask is because apparently there's a bunch of articles online right now where Gen Zs or Zennials or however they want to call the current age group of college students is they don't understand folder structure and they don't understand what files are. And I was pretty sure they're more likely talking about people who are not in engineering or science fields and aren't used to using computers a lot. So, okay. Yeah, that's what I expected, but I just wanted to talk about that. Anyways, so packages are just the folders. So if you went and looked in Explorer, you would see a UI folder, and inside that you would see a widgets folder. But what if in this widgets folder I have, let's make it a silly number. Let's say I have 10,000 files. Red button, green button, blue button, whatever. And goes down the list. And then there's circle button, or you can think up all the variations. Green circle, etc. If you go star here, it'll include all of them into your source code. Potentially, depending on how you define your compiler. But by default, it will. And so that's bad. So you don't want to do that. Once you are using 5 or 6 roughly classes in a package like this, most modern packages are going to be designed well so that the star isn't going to impact you as negatively. Because they try to keep down the number of libraries try to keep down the number of objects in a single package like that. So in general, just try to stay away from the star. It is technically legal syntax, but it can severely impact your code. Okay, so notice I named all my repositories lowercase, and I named my classes uppercase first letter. So this is called what's called Pascal case. Pascal, there's a programming language named Pascal. It's named after Blaise Pascal. He was a scientist, mathematician. Basically, I think he was the first person that invented the concept of noise pollution. A really interesting person historically. You should look him up on Wikipedia and deep dive through all the things that he's done. But it's called Pascal case because the programming different cases, case types. Yeah. So here's Camel Case. You'll notice if you look at it, there's a hump in the middle from one uppercase word. So we call it a camel. Yeah, programmers are not... We think we're very funny, and we are to us with very dry sense of humor. Snake Case has... It's dragging its belly on the ground, so it's a snake. Kebab Case, because you're skewering the words. Pascal case, uppercase snake, different Go conventions, JavaScript, Ruby. They have different use cases. So you'll notice, I come back over here, I followed the convention without even really talking about it, but this would be, it's uppercase snake case. Or how did they phrase it? Uppercase snake case. For static variables. Oh, I didn't cover final. Final is another one of those topics like static that actually has more that we won't get into. But let's just, for now, say that the value of a built-in type can never change, and the instance of the object, if you create an object, can never change. So let's run this. Okay. Oops. Okay. So a list can never be reassigned. This should throw an error. Cannot assign a value to a final variable. But get rid of final, execute it, perfectly fine. Now, this has implications. Actually, anyways, I won't show you. I was going to show you. But if you you put this code here, you would erase all this data that had been stored in a list, and you would make a new array list. I think you can understand that concept. I don't need to go through it more in depth. But, so there's these concepts of packages are lowercase, camel. Classes are in Pascal case with the first letter uppercase. What we consider constants, they're not technically called that, but final static methods or public static, I think there's some wiggle room in that, but static variables that don't change, so generally final static variables, are in uppercase snake case, like tag. Tag's only one word, so it doesn't need underscores on either side. These are conventions. Some of them depend. I don't know. Honestly, I'm not even sure if Java has allowed you to break these conventions for packages or classes anymore, but you don't, because this is what makes the code readable. So just follow these practices, basically. Does that make sense? It's just something, even if it's not enforced by the compiler, you should do it so that your code is readable. That makes sense to everybody? A lot of programming is knowing conventions, essentially. Okay. Earlier I talked about how I'm configuration over convention. There is a push for programming languages to be convention over configuration, particularly when it comes to infrastructure as code or things along those natures, where you're generating code based off of a model file, which you don't need to worry about if you don't understand what that means. But basically, you're writing an input to a program that generates, like, runs servers or sets up a environment for you to develop in, things like that. And I actually think that that's really harmful for novice or developers who are learning that methodology, because my opinion is, if you don't already know the convention, how do you know what's running and what you need to put? So if you just saw a list of configuration variables, you could say, oh, number of servers equals 5. Oh, okay, well, I want 5. But if you didn't know default server is like Ubuntu, and it was just left blank, and all you knew that it was like, you just typed that and it just magically worked, but you had to go look at the default config somewhere in the documentation to figure out how many servers, what type of servers, things like that. I think that's less useful. So that's what I meant by that earlier. It's not as big of a deal when it comes to Java and basic object-oriented programming. But if you ever find that a method is convoluted and you don't quite understand it even though you're the one writing it, explain. This method does X, Y, and Z because whatever. If you're writing a method that's complicated and it needs to do that math for that reason, document it, explain it, so that you're reducing. I have written code like, and 5 years later came back and read my explanations and be like, because I'm a little inattentive when it comes to documenting like this, and it has saved me so much hassle. So that's another concept to be aware of. Something that will even and let's be honest. Let's say today or Thursday you start writing some code, and I make the assignment due for Tuesday. What day are most of you going to do the assignment? Either Thursday night, because you just want to get it done and over with, or Monday night. There's not much middle ground. If you're doing it Monday, you're probably going to forget exactly what I said in class. Well, now there's video, but you get the point. So documenting your code like this is really useful. Okay. That makes sense to everybody, right? Document your code, make it make sense. Let's see, what else is there? Only have a couple minutes left, so we got into the idea of basically how classes are organized through packages and the convention for declaring packages, using importing them in other places in your code. Notice I would not need to declare the import if I'm using a class inside the same package. So if I'm writing text button, I could just directly import or extend button, and I wouldn't have to import it. Just something to know. It works nice. But Thursday we'll go ahead and end now, just a couple minutes early, so that you have time to get to your next class or whatever the case is. And Thursday I'll download and install the IDE from Intellij, and we'll start actually thinking about how are we going to make actually usable complex code, and we'll start talking about the actual assignments from there. So, because obviously assignments on like JDoodle are not super efficient, so we'll go from there. Anybody have any questions before we head off? No? All right. Then we'll go ahead and end here. And as we said last time, you all come back now. You're here. And if you have any questions, if you want to go ahead and download it, you're more than welcome to. I'll be walking you through its setup and configuration to make reasonable defaults. So the download and installation only takes like 2 minutes. So if you have slow internet at home or something like that, feel free to do it beforehand. At least download it. We'll go ahead and end there. And if you have any questions or comments or whatever, obviously class chat server is always up. All right. Have a good one, everyone.